Good morning. Myself Prabharanche, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is MOS IV characteristics from Unit 1, that is MOS transistor principle. From the subject name is VLSI system design. Okay, let I discuss. Before that, we should know about the introduction of MOS transistor. Uh, MOS metal oxide semiconductor transistor, particularly MOSFET, are widely used in both analog and digital circuits. Understanding their current voltage characteristics is essential for analyzing and designing electronic circuits. Then followed by we will see the MOS structure. It has, that means MOSFET has four terminals. First one is gate, drain, source, body. Okay, there are two types of MOSFET. First one is N channel MOSFET, and which is called NMOS, and P channel MOSFET, which is also called PMOS. Okay, there are three types of operating region. First one is cutoff region, saturation region, and linear region. The behavior of MOSFET depends on the voltage applied to its terminal. The two key voltages are VGS, which means gate to source voltage, and BDS, which means drain to source voltage. Okay, this transistor, gate, source, and then drain all have capacitance. uh, the equation is like I equal C into dV divided by dt, which means we can write dt equal C divided by I into dV. I is nothing but the current value, C is nothing but the capacitance value. Let I discuss the some of the introduction to mass capacitor and followed by the working principle in different regions, different operating modes. Mm, let me see introduction to MOSFET. The metal oxide semiconductor capacitor. A mass capacitor is a fundamental building block in MOSFET devices and is essential for understanding the operation of MOS transistors. And the gate terminal will act as a one plate of capacitor, and then semiconductor terminal, which is substrate, will act as a another plate of the capacitor. Then dielectric medium act, the SiO2 layer act as a dielectric medium. The working principle of mass capacitor is when a input voltage VG is applied, which means gate terminal voltage is applied, it affects the charge distribution in the semiconductor below the oxide layer depending on the polarity and magnitude of the applied voltage, which means input voltage VG. The semiconductor undergoes different operating region. um, Operating regions in mass capacitance is mm, accumulation operating mode, and then depletion operating mode, and then inversion operating mode. Let I discuss the how the mass capacitance in accumulation mode and depletion mode in inversion mode. In accumulation mode, the condition for Vg less than 0, which means the negative voltage at the gate, which due to this, the majority carriers attract to the surface. Surface become more p-type capacity. Because of this, capacitance is high. It close to oxide capacitance, which is C suffix oxide. Then in depletion region, condition for depletion region is Vg, V suffix C greater than 0 and less than threshold voltage, which means small positive voltage the gate terminal. Uh, Due to this, repulse majority carriers, leaving behind fixed negative ions, forms a depletion region with few mobile charges. Capacitance decreases as depletion with increases. And then in inversion mode, the Vg greater than Vt, which means input voltage greater than threshold voltage. So large positive voltage at the gate terminal. Because of this large positive voltage, the majority carriers attract to the surface. A thin layer of inversion electrons forms, then the surface becomes n-type. Capacitance stabilizes at a lower value due to maximum depletion width. These operation modes depends on different terminal voltage, that is gate terminal voltage, drain terminal voltage, source terminal voltage. Then gate source voltage, which is equal to gate terminal voltage difference between gate terminal voltage and source terminal voltage. Similarly, gate drain voltage, which is equal to gate terminal voltage minus drain terminal voltage, that is difference between gate terminal voltage and drain terminal voltage. Similarly, drain source voltage is defined as the difference between the drain terminal voltage minus source terminal voltage. Also, you can see the MOS transistor diagram here. Source here in between source terminal to gate terminal voltage is VGS is represented as VGS. Similarly, VGD and VGS. Here you can apply the Kirchhoff voltage law. We will find the VDS equal to VGS minus VGD. Also, already we have discussed there are three types of operation regions. One is cutoff region, another one is linear region, and next one is saturation. Yeah, here you can see the NMOS transistor diagram, and substrate is P type, and both left side and right side you have to diffuse N type diffusion, and take left side on the N diffusion source terminal, right side drain terminal. In between that there is one thin SiO2 layer. After that, small aluminum material formed small aluminum material. In that aluminum material, take one terminal, that is called gate terminal. In between gate and drain terminal, the voltage is VGS. Similarly, gate to drain terminal voltage is represented by VGT. Okay, there is three terminal. First one is source and gate and drain terminal. Source to gate voltage is VGS, drain to gate voltage is VGD, and body is nothing but the P-type substrate. And in that cutoff region, the transistor is in off state, so there is no current flow, so that IDS equal to 0, there is no channel also. Okay. Here you can see NMOS linear region. Linear, there is one condition: gate source voltage greater than VT, which means threshold voltage. Okay, so uh, the current flow starts from drain to source, then form a one channel. So IDS, which means current is represented by IDS, drain to source current. IDS increases with VDS. Similarly to linear resistor also. Next is current flow in NMOS saturation region. Here we have two conditions: VGS greater than VT and VGT less than VT, which means gate source voltage greater than threshold voltage, gate drain voltage lesser than VT voltage. At this point, channel pinch off will occur. Channel pinch off is refers to the nothing but the condition in a MOSFET where the inversion layer, which means channel near the drain end becomes depleted of charge carriers, effectively pinching off the channel at the end, and also the drain source current is independent of VDS. Okay, the channel length is gradually decreased at this region. Next is channel charge. You know, is nothing but the capacitance into voltage, uh, which means here channel charge is represented by Q channel and equal to C into V. Also, C is nothing but the gate capacitance, which is equal to E oxide W, width of the channel and length of the channel divided by T oxide, thickness of the oxide layer, which is equal to COX into W into L. Also, V equal to potential difference, which is BGC minus BT equal to BGS minus VDS divided by 2 minus BT. This is the channel charge equation. Next, carrier velocity. Charge is carried by electrons. Carrier velocity is nothing but the V, which is proportional to electric field between source and drain. The carrier velocity, which is equal to mobility into electric field E, and electric field, which is equal to VDS divided by L, which means drain source voltage divided by length of the channel, and time for carrier to cross channel equal to T equal to length of the channel divided by velocity V. Then let me do one activity. Can here you can see the diagram. Can you put the numbers 1 to 7 in the circles so that every line adds up to 12? You can use each number only once. Okay, okay. You can comment me your answer. You can comment me. And next is NMOS linear IV characteristics, which, uh, which is nothing but beta. Beta equal to mu into C oxide into width of the channel divided by length of the. And finally, we get the NMOS IV summaries. For IDS equal to 0, current is 0 for cutoff region, and current have the value beta into VGS minus BT minus VDS divided by 2 into VDS, which is the linear condition, and saturation condition beta divided by 2 IDS value equal to beta divided by 2 into VGS minus VT whole square. And these two assessment questions for these lecturers. First question is compare accumulation, depletion, inversion mode, and second question is write the current value for the three modes: cutoff region, saturation region, and linear region. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.